Here we are in section 5.5 where we are trying to find the real zeros of a polynomial function. And there's several ways to do it. We're going to look at some of the most popular. And we begin with what is called the factor theorem. And what we are asking is, we're going to use the factor theorem to determine whether or not x minus c is a factor of f of x. And several things that we need to do here. First of all is look at the problem and then how to decipher it, and then once you decipher it, it's relatively simple to do the actual calculation. F of x is equal to x to the fourth minus 5x squared minus 36, and we're asking, is x minus 3 a factor of that? Well, basically what we need to realize is the factor theorem says x minus this. We can 3. And what we can do is we can actually plug in 3 in for x. In other words, it's x minus whatever. So if this was a plus 3, then we'd put in negative 3. It's the exact opposite sign. But realize that our goal is to get an answer of 0. And if it is, we'll go one way. If it's not, we go a different way. So let's plug in 3. 3 to the fourth minus 5 times 3 squared minus 36. Well, 3 to the fourth is 81 minus 5 times 9 minus 36. 81 minus 45 minus 36 equals, I believe that is 0. Since it does equal 0, then the answer is yes. X minus 3 is a factor of x to the fourth minus 5x squared minus 36. If it turns out to be any other number besides 0, the answer is no. So number 2, we have f of x is given, and we're asking x plus 11 fifths. Well, all we have to do is plug in negative 11 fifths into f, and if that equals 0, we're good. If not, we need to say no. So that would be 45 times negative 11 fifths cubed plus 89 times negative 11 fifths squared minus 42 times negative 11 fifths minus 44. Okay, lots of nasty fractions, but it's just something we have to deal with. So this is 45 times a negative 1,331 over 125 plus 89 times 121 25ths. Going ahead and multiplying this out, we get 462 over 5 minus 44. Okay, now multiplying this out, we get negative 11,979 over 25 plus 10,769 over 25 plus 462 over 5. This should be a 125. No, it shouldn't, sorry. Minus 44. And basically, once we punch all this in or determine this, this does not equal 0. And therefore, no, it is not a factor. Example number 3. It's x plus 4, so I'm going to put in negative 4 in for f, and it's 7 times negative 4 cubed plus 26 negative 4 squared minus 7 times negative 4 minus 4 equals 7 times negative 64 plus 26 times 16 plus 28 minus 4 equals negative 448 plus 416 plus 28 minus 4, which equals negative 8. So no, it is not a factor. Once again, remember that in order for it to be a factor, it has to equal 0. Okay, number 4 asks the same question, but it asks a further question. And so what we need to do is we need to first of all do exactly what we did. F of 1/2 equals 6 times 1/2 cubed plus 7 times 1/2 squared plus 13 times 1/2 minus 9 equals 6 times 1/8 plus 7 times 1/4 plus 13 halves minus 9 equals 3/4 plus 7/4 plus 13 halves minus 9. And when this is all said and done, it does equal 0. So yes, it is a factor. Then we need to write it in factored form. Now, one thing we need to do here is we know that x minus 1/2 is a factor. So that means x minus 1/2 is one of our factors. What would the other part of it be? Well, this is where we need to go back and if we look at synthetic division says take the 1/2, and I'm going to put the coefficients of 6, 7, 13, and negative 9 in, and remember we should get a 0 here. We drop the 6, then we take 6 times 1/2, which is 3, that goes here, add. 10 times 1/2 is 5, add. 18 times 1/2 is 9, add. And we do get 0, but now we need to decipher this. Well, this is 6x squared plus 10x plus 18. And so that would be the final answer, the second part, because the first part was, yes, it is a factor, and now we had to write it in factored form. So it's x minus 1/2 times 6x squared plus 10x plus 18. Example number 5. It says list the potential rational zeros of the polynomial function, but we're not supposed to find the zeros. Now how we do this is very simple. We look at number 5. F of x equals negative 2x cubed plus 4x squared minus 3x plus 8. The possible rational zeros. What we're going to do is we're going to take this last term, the constant here, and we are going to list every factor of 8. So that would be 1, 2, 4, and 8. We're going to put those numbers in the numerator. Then we're going to take all of the factors of this and list those in the denominator. So 2 will be 1 and 2. Now all of the possible rational zeros will be any combination of these two numbers, 1 over 1, 2 over 1, 4 over 1, 8 over 1, 1 over 2, 2 over 2, 4 over 2, 8 over 2, and it can either be positive or negative. So to answer this question, it'll be positive 1 over 1, which is 1, plus or minus 1, 2 over 1, plus or minus 4 over 1, plus or minus 8 over 1, plus or minus 1 over 2, Plus or minus 2 over 2, which is 1. We've already said that. Plus or minus 4 over 2, which is 2. We've already done that one. Plus or minus 8 over 2, which is 4, which we've already written. So these are all of the possible rational zeros for number 5. Number 6, same thing. I'm going to list the factors of the last number, which is a 6. So it's going to be 1, 2, 3, and 6. And the factor of the first one, which is a 1. And that makes it very nice. Then just combine everything up here with everything down here. Plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, and plus or minus 6 over 1. And that would be the answer for number 6. Okay. We will continue with example number 7 on the next video.